Okay, in this video, we're going to talk about some basic rules of algebra, things that you probably know, but let's go over them, okay? So, there's some vocabulary I want to make sure we know. We talked about a little bit of vocabulary earlier, but when I have what's called an expression, we're going to have some x, y, z's now, finally. If I have 7x, that's an expression. That 7 is called the coefficient. And that letter is called the variable. Okay? Together we would call these an expression. Okay, the relationship here between coefficient and variable is one of multiplication. Okay, that's saying 7 times x. Okay, I make like a cursive x. That's my x. I try not to in algebra. I know I've done it in some of these videos. I try not to use the old classic times sign in my algebra classes so as not to confuse with x. Okay, but I make them different, so I never confuse myself, but not everybody does that. So, but I try not to. But here we have 7 times x. So in algebra, there's lots of different ways to show times. Okay, and again, we could write 7 times x, but we usually don't put that classic times sign in there. And we don't need anything when it's a number and a letter side by side, or 2 letters, x, y, that means x times y. But 2 numbers, I have to do something, right? Now we're used to 2 times 3, but I don't like the x, so there's some other ways. A dot, 2 times 3 with a big old dot there, not a decimal point, not a little dot, a big old dot in the middle. Sometimes you'll see the star character, that's what the computers use, right? Parentheses, one number in parentheses or the other or both. All of these things mean multiplication. So we have to look out for all that. Okay, they all mean the same thing, times. Okay, and if it's a number and a letter, there's nothing there. 2x, that means 2 times x. All right, so as we start putting together these expressions, when we're adding and subtracting, they're called, these are called terms. Okay, we're looking for what we call like terms. Okay, like terms, okay, meaning the exact, what is a like term? An exact matching variable. Okay, not the coefficients, not the number in front, the letter has to match. And once I have, once I have matching letters, I call those like terms. When I have like terms, I can add and subtract them. Okay, so if we have, for example, 4x plus 3x, they're both x. They have like terms. I can simply combine them and call that 7x. Okay, 4x plus 3 is not a like term because the 4x and the regular old 3, which we call a constant, by the way. Okay, those are constant term to be more specific. Constant term and this together makes up a variable term. It's got these 2 parts, but we call it a variable term. Okay, variable terms and constant terms make up these things we call expressions. Well, I can't add them unless they're like terms. So 4x and a regular old 3, no way. A 4x and a 3y, no way. Can't add them. They're not like terms. A 4x and a 3x, yeah. Okay. So I'm looking for like terms, and I'm going to remember some properties here that we're going to talk about that it's going to allow me to simplify things a little better. Okay, how about if I have this? 4x plus 5 plus 6x. Now, I've got this 5 in the middle, but I've got the 4x and the 6x that I should be able to put together, right? Well, we're going to learn something called the commutative property that allows me to shuffle stuff around, okay? I can shuffle this. I can put the 4x and the 6x side by side and just cast the 5 off to the side there, and now I can say, aha, those are really 10x plus 5. And now once you get the swing of it, which it doesn't take long, I mean, we'll just right here, the first step, we'll see a 4x and a 6x, we'll call it 10x. We won't have to rewrite it. Okay, but we'll understand we can use these properties, the first of which is called the commutative property. Oh yeah, I remember hearing about that back in the day. Commutative property, all that's saying is something we already know. 2 plus 3 is the same thing as 3 plus 2, right? Or more generically presented, some A plus B equals B plus A. All right, the order is not important when we're adding. Commutative property holds for addition and multiplication, not subtraction and not division. Okay, addition and multiplication. Shuffle the order. Okay, so that's an addition example. A multiplication example, 2 times 3 is equal to 3 times 2. They're both 6, right? So some A times B equals some B times A. All right, so let's use this property. And let's simplify some things using this property. What if we had, we'll just do the addition one here for a minute. 4x plus 5 plus 3x plus 2. Okay, you see I've got x's and I've got regular constants. I'm just going to mentally switch them. I'm going to put them side by side mentally. I'm going to say, hey, 4x plus 3x is 7x, and 5 plus 2 is 7. I just happen to get a 7 for both, and that's how we're going to simplify something like that. Okay, mentally shuffle it around. If you want to really physically shuffle it around, you can, but it's not necessary. Okay, you got just mentally do it. All right, so that's the commutative property. The associative property is next. Okay, now what's that saying? Again, this is for addition and multiplication. What's it saying? Well, let's say I've got 2 plus 3 plus 4, okay? If I wanted to group the 2 and the 3 together, okay? Or if I would rather group the 3 and the 4 together, okay? The associative property is telling me that these two things are the same. Okay, they're the same. So are they? Let's see. 2 plus 3, that's going to be a 5 plus 4, supposedly equals 2 plus 3 plus 4 is 7. Yeah, they look pretty good to me. All right, so the associative property says I can group things any way I want as long as it's addition or multiplication. So some A plus B plus C, whether I group it this way or whether I group it this way, doesn't matter. Okay, multiplication also. I could take A times B and then times C, or I could do B times C first and then times A. It doesn't matter. Okay, same value. Okay, all good there? So we can use these properties to help us simplify a couple things here. Okay. 3 plus, 8 plus x. The 8 and the x are grouped together, and we can't put an 8 and an x together because they're not like terms, right? But the 3 and the 8 are like terms. I could put them together. So the associative property, and again, we'll do this more mentally than anything, says, let's just group the 3 and the 8 together, and then we'll add x later, because we don't know what x is right now. 3 and 8, I can figure that out, and I'll worry about x later. Okay, so even though the 8 and the x were grouped together, it's all addition. I can regroup it differently and put the 3 and the 8 together. Okay, 8, times 4x. Okay, well, I'm supposed to be taking the 4 times x. We're going to talk about this thing called order of operations. I'm supposed to do what's in the parentheses first. Okay, and then 4 times x are in the parentheses. I'm supposed to do that first, but I don't know what x is. If I knew what x was, then yeah, I would take 4 times whatever x is and then times 8. It doesn't really matter, but I don't. So what I would like to do is, I'm going to use the dot now. I would like to do the 8 times 4 first, and then I'll multiply by x later, because I don't know what x is. 32x. Okay, so that's how we're going to simplify stuff like that. All right, the next property is, we're going to use a lot, is called the distributive property. Okay, what's that saying? Well, if I've got some number in, some operation happening inside of parentheses, like I've got 7 plus 4, but now I've got a multiplication outside of that parentheses, so like a 2. So this is really 2 times this quantity in parentheses known as 7 plus 4. Well, order of operations, again, which we haven't talked about, but it says you're supposed to do what's in the parentheses first. So we're supposed to put the 7 plus 4 as 11 first. So it gives me 2 times 11, which gives me 22. Okay, and that's fine and dandy. There's nothing wrong with that. But there is an alternative. Okay, I can take that same problem and I can do what's called distribute the 2 across the parentheses. Okay, it's really 2 times 7 plus 2 times 4. So let me write it out. 2 times 7 plus 2 times 4, which is really 14 plus 8, which is that same old 22. Okay. Now you might be saying, that looks a lot more complicated than that. Why would you do it that way? The other way, it looks easier. And if they're all good old numbers, you're right, it is easier. But what if we have this? 3 times 2x plus 4. Well, now I don't have the option of adding my 2x and my 4 together because they're not like terms. So now all I can do is distribute that 3 across. I'm going to get 3 times 2x gives me 6x plus 3 times 4 gives me a 12. Okay. Now, mental note here. Ready? We're going to talk later about the process of factoring. And factoring, part of factoring, is like undistributing. If we started here, we would ask ourselves, well, actually, in this case, we could factor out more than what I just did. So this is really not a great example. My apologies. I won't even go into it then. We can actually factor out more than just a 3 here, but it's the process is what I was wanting you to think about. I put the 3 in. How can I get the 3 back out? How can I extract that 3 back out of there? And in this case, we can actually extract out a 6. So we'll shelve that discussion, but I just want you to start thinking about how to go backwards with these examples as we move forward. Okay. So let's just do a few of these that involve multiple things cooking at once here, shall we? That sounds like a winner. Let's do. Let's do. We've done one like this, but okay, we'll start out easy. 7x plus 5 plus 3x plus 8. All we're doing is combining like terms. There's no distributing. We're just using the commutative property and shuffling stuff around. The 7x plus 3x gives me a 10x, and the 8 plus 5 gives me a 13. Got it. Okay. 4x plus 7y plus 3x plus 1y. The 3x and the 4x is going to give me a 7x, and the 7y and the 8y is going to give me a 7y and the 1y is going to give me an 8y. Okay. Incidentally, 1y is the same thing as just y. And a lot of students are bothered by this. It seems like it's not. Well, remember the relationship between coefficient and variable is one of multiplication, okay? 1 times 5, we just call it good old 5, right? 1 times 10, we call it good old 10. 1 times y or x, we can just call it y. We don't have to call it, we don't need the times symbol here, of course. Okay, 1 times y, we don't have to show that 1 there. And most of the time, you won't see a 1, but you have to really understand it's there. These two things are the exact same thing. And you don't have to show a coefficient when it's a 1. You just have to recognize it's there. Okay, so I put the 1 in there, but a lot of times you won't see a 1 in there. You still need to pick up that it's there, okay? All right, let's do a couple more here. Why don't we take let's say 5 times 3x plus 7, but then I'm going to add 6x afterwards. Okay, so what do I have? I have a distributing process there over that first parentheses. 5 times 3x is 15x, plus 5 times 7 is 35, but then I've got plus 6x coming on down. Now that does not get multiplied by 5, right? Because that's just coming down. So I have to add the 15x and the 6x together. That'll give me a 21x plus 35. Okay. What about this next one? Yeah, this one's a little more of a doozy. I like it. 6 parentheses, 2x plus 4y plus 10 parentheses. Notice we haven't had a lot of negative numbers. That's because we haven't really talked about negative numbers yet. We'll get to that. Okay, everything's been kind of nice and pretty and positive here so far. Distribute twice, combine like terms. Okay, so 6 times 2x is 12x, plus 6 times 4 is 24y, plus 40x plus 30y. All agree? Combine my like terms. A 12x and a 40x, that gives me what? 52x. And a 24y and a 30y is going to give me a 54y. All right, that's kind of it for these rules of algebra. We're going to start talking about adding and subtracting and multiplying and dividing what we call real numbers, which of course is really easy until you get the negatives mixed in there, and even then it's not quite so bad. I want to make sure we got the gist of this calculator, which is a little different from others. Okay, so the next video I will start talking about that topic.